Welcome to this class. In this session, my colleague Mantas and myself will present possible ways to generate the different levels of visualization to improve communication for a transportation project. My name is Claudia Zeh. I work as implementation consultant and have been with Autodesk Consulting since 2005. With more than 15 years experience in GIS and the geospatial domain, my focus lies on helping AEC customers deploy Autodesk tools for workflow and solution development around infrastructure projects.
Good day, everyone. My name is Mantas Schmittes. I'm a senior implementation consultant and have been with Autodesk Consulting since last year. I have more than 15 years experience in GIS, BIM, and 3D design technologies. I'm specializing in integrating GIS, BIM, 3D modeling and visualization around tools including Civil 3D, InfraWorks, 3ds Max, Revit, and BIM 360. I have diverse experience to engagement from a background in rail, road, airport, urban design, building, and media and entertainment. With this, I will hand over back to Claudia.
The content of the session is based on a project we worked on together with Max Bögel, a German construction and infrastructure company. Max Bögel designed a fully automated urban mobility solution, the Transport System Bögel. As it is a new transport system, an important part of the bidding and early design phase is to generate convincing visualizations representing the design track and explaining the system. This class will highlight the main steps of the solution: the creation of the track and the 3D visualization model using InfraWorks and Civil 3D, the workflow how to create enhanced visualizations based on this model by animating specific parts using 3ds Max, the aspects that needs to be considered when creating a convincing visualization, and how this model and data can be used with VR/AR solutions. Before looking on the technical solution, we'd like to give a bit of background information about Max Bögel and the new transport system. Max Bögel is one of the largest construction companies in the German construction industry, with many years of experience and competence in high-precision precast concrete construction. One of the key characteristics is innovation in research and technology to develop new solutions, including topics such as renewable energies, urbanization, mobility, and infrastructure. The Max Bögel Group has already been involved in magnetic train technology for over 20 years. The development of the TSB began in 2010. It is a future-oriented local transport system, and as it is based on magnetic levitation or maglev technology, the system is quiet and flexible while also saving space and lowering emissions. The main emphasis of the system lies on providing a sustainable solution of a transport system for densely populated areas. It's intended for shorter distances. So, for example, it could be used to close the gap between a larger rail station and an industrial park. Another important aspect is that the whole solution is from one source. As a turnkey supplier, Max Bögel is responsible for the planning, for the industrial manufacturing of the track and vehicle, and the construction measures. This is as well resource and cost efficient, which makes it possible for the infrastructure project to be completed in a short time. The TSB is a driverless passenger transport system and is designed to go on a speed of 150 kilometers per hour. The first demo track has been built in China. It's a construction of 3.5 kilometers demonstration track, the picture on the lower right-hand side. For the construction, Max Bögel works together with a partner in China, but all components have been delivered from Germany. Also the vehicle, for example, as you can see on the top image. Another big step was in summer 2020, when the German Federal Railway Authority has given assurance that the core components comply with requirements and are eligible for approval. Still, as it is a new transport system, Max Bögel needs to do persuasive work to convince future clients of the new system. When the Max Bögel TSB team approached Autodesk a couple of years ago, the main ask was to support in finding a quick way for creating early design visualizations. There were really two main asks. finding a quick way to generate the TSP track design in context of the existing environment. The emphasis here mainly lies on quick with not too much effort. Especially for the bidding phase, it is important to be able to quickly generate a model containing the existing environment to be able to show where a new TSP track will be planned. The other requirement was to generate a realistic visualization of the lightweight track. As the way how the track is designed is an important part of the whole system solution, the Max Bögl TSP team placed importance on the ability of being able to exactly show this in the visualization model. When we, Autodesk Consulting, started with the first project with the TSP team to find a solution answering these two main asks, we introduced the InfraWorks Civil Structure Design. InfraWorks is a tool that allows to create models with large extents to show the design in context of the existing environment. With a model builder, which is part of InfraWorks, it is possible to create existing condition models quite quickly. You define a boundary of your area of interest and will get a model containing terrain data, ground images, buildings, roads, rail, water network. It leverages publicly available data. This is very handy. The level of detail or quality depends on the data that is shared publicly. Still, this is a very quick way to start with your base model, and then it's really up to you to add or replace data with better quality data. For the track design, you can either start with designing the track directly in InfraWorks, or you can import the track from Civil 3D, which has the benefit of allowing a more precise design of the alignment and profile. When importing a Civil 3D alignment, you also benefit from the possibility to update the track in InfraWorks automatically by refreshing the Civil 3D's data source. With this step, you have defined how the routing of the track is planned in your model. Now, for the actual visualization of the TSP track, we made use of the InfraWorks bridge design capabilities. The InfraWorks bridge is based on parametric model components, which can be highly customized using Inventor. InfraWorks already contains a library of ready-to-use bridge components, but in this case, as it was important to exactly generate a model that reflects the TSP track design, we generated custom models, for example, for the piers and for the girders that reflect the actual TSP. Now, on this slide, you see some examples of the generated models. On the left side, you see pictures taken from the TSP test track at the Max Bögl's headquarters in Sengenthal. On the right side, you see images taken from sample InfraWorks models showing a pier, the elevated track, and the TSP vehicle on the track. The important part of the TSP track is to show that it's not a complete concrete slab, but allows sunlight to pass through, which is critical in already densely populated areas and an important part of the lightweight track design. These are additional sample images taken from InfraWorks models. With InfraWorks daylight analysis, it's easy to generate visualizations that show, for example, the shadowing. So for this part, the main emphasis lied on how to generate the InfraWorks model and the custom Inventor components to best visualize the designed TSP track. After successfully creating these visualization models, the Max Bögl TSP team decided to take the next steps towards generating enhanced visualizations, including animations. Max Bögl developed a new variation of the TSP transport system, the TSP Cargo. Using the same maglev technology, TSP Cargo is a sustainable, low-emission system for moving containers. The basic technology and structure is the same as for the TSP passenger system, lightweight track, driverless transportation system. But with this TSP Cargo, it became even more obvious how important it is to be able to visually explain the system in action when talking to potential clients who are interested to understand all details. So based on the TSP track visualization generated with InfraWorks, we worked together with the Max Bögl TSP team to share best practice how to generate animations. With this, I will hand over to my colleague Mantas, who will give some insight into the enhanced visualization part.
Thank you, Claudia. Based on requirements we got from client, we had to find the best possible way to visualize technical project data. We also have to gather and exhibit this data into the common data environment. Our proposed workflow through the coordination model allow project team use all design data they collected in early stage and reuse it again in the coming project stages, where they can make higher quality visualizations, movies, or maybe can start build interactive VR, AR games. Max Bögl team already has experience on how to build their project in InfraWorks environment, but they don't have any experience on how to prepare and animate 3D models in the 3D Studio Max, and send them back to the coordination model for creating high level of details. To solve that, we prepared 5 high-level workflows to help our clients to deliver more accurate technical visualization, increase visual quality in the coordination model. We also add a possibility for virtual experience. So these are 5 steps we proposed to our client. First one was on how we can improve existing project environment for early phase design. Step 2, we investigated best practices on how to animate 3D project in 3D Studio Max. Step 3, we learn on how animate 3D objects and camera animation workflows can improve the technical presentation. Step 4 was about new techniques on how to increase level of detail and create higher visual quality. Step 5, we investigated quick ways to generate more value by using InfraWorks and 3ds Max models. So on first step, we looked into the existing project environment and early phase design. This workflow was about the best practices and how client can use existing national sources to build the project environment. We proposed clients to answer a couple of questions before they can start building the project environment. We asked you to think and ask yourself about data input. For example, what data sources do I have access already? Do we need, or what do we need to purchase to increase the level of details in our coordination model? We ask clients to think about the level of details they need for this project from the beginning stage to the final project stage. For example, what detail do you expect to see in your final 3D model or final visualization? To think about the model size and model setup. For example, which areas do you see in more detail level on your final 3D model? Also think about what are you planning to design in the coordination model. If you need alignment, maybe you need to split 2 long alignments into the smaller sections. Think about other file types you need to import later to your project environment. Maybe there will be Revit structures. Maybe some of these 3D elements needs to be animated to show the way it works. So the images in these slides showing how different information layers can increase your model quality. Step 2 was about the best practices on how to animate 3D objects in 3D Studio Max. For this specific project, we need to understand and learn principles of animation in 3D Studio Max. We need to learn how to animate and automate the animation process for TSB models like TSB Cargo, TSB Crane, racks, switches, and other 3D models. We looked at TSB structure because we understand that all models are made differently. For example, we had a 3D models was made in Inventor, SolidWorks. We had an OBJ object models and 3D DVG models as well. We need to understand how details should fit the desired automation, especially if it fits the mechanical movements. We looked into the model simplification methods, best practices to combine compound 3D elements, how to work with layers and create model hierarchy, how to understand point of origin, existing pivot points, automate animation process using 3ds Max attribute creators. Step 3 was about animated objects and camera animation workflows in 3D Studio Max. Project environment we create in the beginning of this project allow us to combine existing environment model with the animated models from 3D Studio Max. In this session, we learn how to create automated animations by adding alignment data from Civil 3D and using Civil View in the 3ds Max, we can animate cargo models on the track we imported from InfraWorks. It works really great with overview animations. We also learn how to build manual vehicle animation. It requires more steps, but gives a lots of flexibility. It's very customizable. For example, if you want to make a stop, slow down, change line, or other manual animation, it's a perfect solution for that. We looked into the best way to import animated objects from the 3D Studio Max. We found the best way to export animation is Cloudifile. And finally, we investigated different camera movement techniques in InfraWorks. For example, how to create camera shots with the storyboard, what are the best angles for camera creation in InfraWorks, investigated best practices on how to get best quality while rendering the movie in InfraWorks. Here we see one of the results the Max Bögl team created after applying the different steps we just talked through. The main emphasis on this video is to explain how TSB cargo system works at the transshipment point. When lifting container from semi-truck and dropping onto the TSB cargo, it perfectly shows the moving part and the flexibility of the system. It also shows how two TSB tracks can be served in the very efficient way. Before I actually clicked on the start button of the video, you will have noticed how this could be difficult to explain to someone who don't know the system very well. And this is really one of the main reasons why it can be very efficient to generate animations and get them into the InfraWorks, where animations can save you a lot of time in the very complex explanations. Also adding details like trees, buildings, high voltage lines, roads and cars into the project environment allow Max Bögl team to create much higher quality model and video directly from InfraWorks. I want to show another example. In this animation, the Max Bögl team has been working on a movie where they can show how the TSB cargo is moving along the track. Being able to control the set speed, this video demonstrates how quick the TSB cargo can transport containers from point A to point B, especially as this scene shows the direct comparison with the driving semi-trucks on the motorway. Given a speed of 150 kilometers per hour, the TSB cargo will be able to transport container quicker from one place to another. Max Bögl team built this track based on the alignment they had created in Civil 3D. This alignment was imported into InfraWorks, where team designed the TSB track as a component bridge element by using the inventor girder component for the track selection. Again, all videos was created and rendered within InfraWorks. Animation of TSB track and cars on the motorway was created with 3D Studio Max and imported into InfraWorks for visualization. Next two workflows we worked on was how MaxBurgle team can create more value based on the core collaboration model. They build through InfraWorks and animation they build in 3D Studio Max. So the techniques we learned enable us to create a better level of detail. All that allows us to work on the higher visualization level and open gates to the virtual and augmented reality. Gives us possibility to create gaming projects as well. We investigated the new techniques on how to increase the level of details and create a high-end visualization through InfraWorks. So we concentrated on how to set up and render scene in 3D Studio Max. We learned how materials can change quality and the way the image looks. We also investigated the best practices on how to import and align InfraWorks model into the 3ds Max scene. Step 5 was about how to create more value by using InfraWorks and 3ds Max models. We built it together with the MaxBurgle team. This simplified workflow show how we can create virtual and augmented reality solution by just linking our 3D model through BIM 360 to the Unity Reflect. Or, for example, how with just a couple extra clicks, you can render a simple 360 panorama image by using Autodesk A360 solution. All these different alternatives allows our client to view their model from different perspectives. And last one I want to discuss today is a VR/AR integration. In this example, you can see how coordination model team built in InfraWorks and 3D Studio Max can be linked directly from BIM 360 to the Unity Reflect, where team can stream your 3D data as a VR or AR solution. And in this environment, you can fly or walk through, you can share your view with others, you can communicate in the same model space, you can link your model in the environment you are surrounded. In this example, I linked my model to my tabletop, and picked the right scale and placed my model on my table. This is the simplest way to create AR solution. So with this, I will hand over back to my colleague, Claudia.
Thank you, Mantas. Now to summarize what we covered as part of this session. During this class, we walked through the different levels of visualization. We quickly strived the early design visualization for the existing condition model and the track design by creating InfraWorks models, gave insight into how animated parts can be created in 3ds Max and how to include them to the InfraWorks models to better communicate the system in action, looked on what needs to be considered and how to enhance the visualization by adding more details to the model, gave some outlook on how to generate VR, AR solutions to provide interactive solutions based on the models created before. And by covering all this, we showed a workflow of how you can reuse the same models, stepping from one level to the next. And maybe obvious, but still important, when generating the models and its components, the required level of detail is really guided by the desired level of visualization that needs to be generated as a final result. Benefits you will gain by creating visualizations with animations and higher quality are, for example, those. You will minimize the time needed to explain a solution compared to, for example, the extra time needed to verbally explain static images, drawings, etc. You reduce the potential misinterpretation when communicating a design. You can make use of animations to explain technical details of moving parts, and you can attract a bigger audience when sharing more appealing visualizations on social media. With this, we want to thank you very much for your interest in this class. Thank you.